Hi guys, we're looking at chapter 23 and now we're at section C, which is expectation. Expectation really is exactly what it sounds like. What do we expect to happen with respect to how many, counting, numbers. Okay, so we're still dealing with discrete random variables, counting in numbers. So expectation means how many of something do we expect to happen. So we have two formulas for that. First one being a simple situation where expectation, E of x, is equal to NP. N represents the number of trials, so how many times we're going to make an experiment, how many days we're looking at if we're talking about probability of days of something, how many trials are happening. P represents the probability of success in each of those trials of the thing that you're looking for. So for example, if we take a look at rolling a die, and the probability of getting a 6 when we roll a die is 1/6, 1 out of 6. Okay, if I roll that die 120 times, how many 6s should I expect to get? Okay, so expectation of getting a 6 would be N times P, where N is the number of times I'm doing this, that's 120. And P is the probability that each time the thing I'm looking for happens, so that's 1 out of 6. So 120 out of 6, which is 20. So if I roll that die 120 times, I should expect to get 26s. Okay, in reality, we know experimental probability, if I actually did that 120, we probably wouldn't get 26s. It'll probably be some other number, but expectation is based on theoretical probability of each trial. Okay, so if we have a more complicated situation where we have a probability distribution, then expectation will be the sum of each xi multiplied by pi, starting from I and ending at n. So remember, probability distribution, xi pi, x means the thing that you're looking for, how many of the things you're looking for. Probability is that happening. Okay, so we're going to have to multiply those together. I'll show you an example down below. First of all, let's look at it let's talk about what this actually means as well. We could write this as x1 times p1 plus x2 times p2 plus x3 times p3, and so on and so on and so on, all the way up to xn pn. Okay, so that's what that means. Okay, the sum of each random variable x multiplied by the probability of that happening, and then all of those added up, so the sum of. Okay, here's a couple examples. Example 5, each time a footballer kicks, he has a 3/4 chance, 3 out of 4 chance of being successful, getting a goal. In a particular game, he has 12 kicks for goal. How many goals do we expect that he should get? Okay, so expectation in this case, N times P, it's a simple situation. Number of times happening is 12 kicks. And probability of that happening is 3 out of 4. Okay, always with any of these, anything in this chapter, you want to be stopping and thinking about what does the random variable x actually represent. And in this case, it represents a successful kick. Okay, number of successful kicks. So in this case, this would be 9. 36 over 4, which is 9. So out of those 12 kicks, we would expect that 9 of them would be goals. Okay. Example 6 is a more complicated situation, so I'll put it here underneath this more complicated formula. We've got the magazine information, the magazine data back from example 2 from an earlier section in chapter 23. So X is representing the number of magazines a customer purchased. And remember, we created this table. So X in a given week, 23% of the customers bought one magazine, 38% of the customers bought 2 magazines, 21% bought 3 magazines, 13% bought 4 magazines, and 5% bought 5 magazines. So to find the expected number of magazines that a person would buy, and another way of thinking of this is average. We can actually go back up here and talk about expectation. Another way of thinking about that is the mean or the average. So on average, how many sixes should we have rolled if we rolled 120 rolls of a dice and did that many times? On average, we would expect to get 20. Okay, so here, on average, our expectation, so expectation in this case is our more complicated situation where we're going to take x1 multiplied by p1, x2 multiplied by p2, and so on. Okay, so in this situation, x1 is 1, so 1 magazine, and the probability of that happening is 0.23. 2 magazines, probability 0.38. 3 magazines, probability 0.21. 4 magazines, I'm going to run out of room here, 0.13, excuse me, sorry, I'm going to have to go down here, and 5 magazines, 5%. Okay, so we're adding all this up. So 2 times that would be 0.76. 3 times this, 0.63. 4 times that, 12.52. And 5 times that, 0.25. Okay, add all those up. $2.39. Okay, which means on average, the expected number of magazines that a customer buys is 2.39, so 2 magazines. But in IB, if they didn't tell us we needed to round it, then we would keep the 2.39. Okay, so 2 different ways of doing expectation. Simple way, simple situation with a simple formula. A more complicated situation, use the more complicated formula. That's it for now.